In this video, I'm going to explain Transit Gateway or TGW in as simple words as possible. So let's get right into it. In AWS, all the resources live in an isolated virtual network called as VPC or Virtual Private Cloud. Normally, many organizations have multiple VPCs in different accounts. These VPCs need to talk to each other. For example, in this diagram, this EC2 instance in VPC 1 might need to talk to this EC2 instance in VPC 2 or maybe in VPC 3. And same goes for communication between VPC 2 and VPC 3. So we need to find a way to connect these three VPCs. One way to establish this connection between these VPCs is to connect these VPCs directly, or in other words, peer them. As the number of VPCs grow, let's say from 3 to 300, this peering also grows because we have to establish one peering connection between each VPC. And you can imagine the number of VPC peering connections. So it becomes a real overhead, very complicated. That is where Transit Gateway comes to our help. Instead of having individual VPC peering connections, we can have single Transit Gateway and then we connect all of our VPCs to this Transit Gateway. And then we decide at Transit Gateway level as which VPC will talk to which one. Now let's see how that works at Transit Gateway level. Consider this diagram. We have three VPCs, VPC A, VPC B, and VPC C. Each of these VPCs have a local route table, and all of these VPCs are connected to each other through Transit Gateway. When we connect a VPC to a Transit Gateway, we call it as an attachment. So basically, we are attaching a VPC to a Transit Gateway. Now, coming back to the route tables of each individual VPCs, let's check out the route table of VPC A. In the route table, we have a destination, which is a CIDR range, and then we have a target. CIDR range is an IP address range which tells us how many IPs can exist in this range. Or for example, if in the case of this VPCA, if we have this range of 10.2.0.0/16, it means that this VPCA can have this many IP addresses. And there are a lot of videos on internet where you can find it, and I will also be doing a separate simple video as how to interpret the CIDR range. But for this video, just focus on the CIDR range, and each of these VPCs have a unique CIDR range. So for example, for VPC A, we have 10.2.0.0/16. For VPC B, we have 10.1.0.0/16. And then similarly for VPC C, we have 10.3. Now, in this route table of VPCA, target is local, which means the traffic will remain within this VPC for any IP range for 10.2.0.0/16, and any other traffic outside of this IP range will go to Transit Gateway or TGW. And same is for the other route tables. Okay, so these three are the local route tables attached locally to these VPCs. But now, as you can see in this diagram, we have also attached these VPCs to the Transit Gateway, which is the purple one in the middle. And this Transit Gateway also has a route table, which is shown on your right hand side. As we attached these VPCs to this Transit Gateway, all of their local routes also get propagated to this Transit Gateway route table, as you can see on this diagram. So the transit, because we have attached three VPCs to this Transit Gateway, we have three routes propagated in this Transit Gateway route table. So what happens is whenever a traffic from VPC A comes to this transit gateway, it goes into this route table, and from there it can access any other VPC B or VPC C. So starting again, let's start from the VPC for the traffic flow. So let's say we are trying to access an IP address which is outside of this local range. So what would happen? That traffic will be sent to this transit gateway because we are saying in this local route table of VPCA that any traffic outside of this local cider range of 16 that should go to the transit gateway. And then the traffic will go from VPCA to transit gateway, and then in transit gateway it will check the route table of transit gateway. And for example, we are accessing an IP range in VPC B. The route cider range of VPC B is this. So transit gateway route table knows that okay, the destination IP address falls into this range, so it will redirect the traffic from again back to transit gateway to this VPC B. So that is how you can control this traffic centrally from transit gateway route tables. And then this is a very simplified explanation of how transit gateway works, what is an transit gateway attachment, and what is transit gateway route table, and how the traffic flow works. There are a lot of other things which you can do in transit gateway. For example, not only you can connect VPC as an attachment, you can connect direct connect attachments so that you could talk to your on-prem or any other destination. You could connect your VPN as an attachment. You can even connect other transit gateways as an attachment to this transit gateway. And then you can also have multiple route tables at transit gateway level as per your destination. For example, one of the best practice AWS tells us is that have a separate transit gateway route table for non-prod accounts or VPCs, and have a separate transit gateway route tables for the prod account. So all the production traffic will go to one route table, and all the non-prod traffic will go to the non-prod route table. So they will be isolated. And then you can configure it as per your own organization rules. So I hope this was useful. If you have any comments or feedback, please put them in the comments. Thank you.